In this video, we're talking about multiplication of rational expressions. And remember that a rational expression is just a fraction where either the numerator and or the denominator is a polynomial, not just a simple whole number. So we've got a couple examples here, and we're actually going to start over here on the right with this second example. We have 3x to the negative 2 y squared divided by z times this other rational expression, x squared z over 3y squared. So we're multiplying these together in order to simplify this expression. So how do we multiply rational expressions? Well, the simplest explanation is you just multiply the numerators together to get the new numerator, and you multiply the denominators together to get the new denominator. It's really as simple as that. However, whenever you're multiplying rational expressions, instead of just right off the bat multiplying through the numerators and multiplying through the denominators, you might want to look to see if you can cancel anything from the numerators and denominators. So you might be able to cancel within a fraction. For example, if we had y squared in the numerator of this fraction and we had y squared in the denominator, we'd be able to cancel that out and we wouldn't have to include it in our multiplication, so it would make our multiplication simpler. Or you might be able to cancel across fractions. Because we're multiplying these together, if you have something in the numerator of one fraction that's in the denominator of the other fraction, you'll be able to cancel those. So looking at this example, we can see that we have 3 in the numerator of this first fraction here. We can cancel that with the 3 from the denominator of this second fraction. So 3 will cancel with 3. What about this y squared term? Well, we have y squared here in the numerator, and we have y squared in the denominator. Because these fractions are multiplied together, we can cancel them out. Notice also that we have z in the denominator of our first fraction and z in the numerator of our second fraction, so those will cancel as well. Now all we're left with is x to the negative 2 times x squared. So we canceled everything else out. This is all that's left over. Now if we remember that x to the negative 2 is the same thing as 1 over x squared, right? When we move this x to the negative 2 to the denominator, it's in the numerator right now. The denominator is an implied 1. If we move it from the numerator to the denominator, the sign on the exponent changes from a negative 2 to a positive 2. So this is 1 over x squared times x squared, and now we have an x squared in the denominator and an x squared in the numerator, and our answer is just 1. So this whole thing here, this rational expression, simplified to 1, we didn't even really have to do any multiplication. We just canceled things in order to get to 1. The other way you could have done it here, instead of changing this from x to the negative 2 to 1 over x squared, you could have used the exponent rule that x to the a times x to the b is equal to x to the a plus b, and said that this is x to the negative 2 plus a positive 2, which would have given you x to the 0, right? Because negative 2 plus a positive 2 is 0, x to the 0, and x to the 0 is 1. Anything raised to the 0 power is 1. So you could have done it that way as well. So let's look at another example here. We have two rational expressions multiplied together. So we have x squared plus x minus 12 over x squared minus x minus 20 multiplied by x squared plus 2x minus 35 over x squared plus 9x plus 14. So because we're multiplying these together, you might think, okay, I'm just going to go ahead and multiply my numerators together and then multiply my denominators together. Well, if you multiply the numerators together, you have a trinomial times another trinomial, which means you have to really FOIL this out. So you have to take the x squared in the first fraction and multiply it by x squared, then by 2x, then by negative 35. You have to distribute. Then you have to multiply x here by x squared and then 2x and then negative 35, then negative 12 by x squared 2x and negative 35. So you're going to end up with 9 terms in your new numerator, not to mention everything you have to do for the denominator. So just like before, what we want to do is see if we can simplify this at all or cancel anything out before we go ahead and do our multiplication. Well, since all of these are trinomials, let's see if we can factor them. We'll start with the numerator of our first fraction here. We have x squared plus x minus 12. If we use the factors positive 4 and negative 3, we'll get plus 4 minus 3 gives us a positive 1. That's what we have in the middle, and we'll end up with a negative 12. So we'll get x plus 4 times x minus 3 is going to give us x squared plus x minus 12. So we can, in fact, factor that numerator. What about the denominator here? X squared minus x minus 20. Well, we would need an x minus 5 and an x plus 4. A negative 5 and a positive 4 will give us negative 20, and negative 5 plus 4 gives us a negative 1, which is what we need in the middle. Then if we look at our second fraction here, x squared plus 2x minus 35, we can factor as x plus 7 times x minus 5, because positive 7 and negative 5 gives us a negative 35, and 7 minus 5 gives us 2, positive 2 there, which is what we need in the middle. So then finally our denominator here, we're going to get x plus 7 times x plus 2, because 7 times 2, positive 7 times positive 2 is positive 14, and 7 plus 2 is 9. So we were in fact able to factor both the numerator and the denominator of both fractions. So now let's see what we can cancel from our fractions. So if I look within each fraction, I have x plus 4 over x plus 4, so I know I can cancel those two. I can't cancel x minus 3 with x minus 5, so let's look at the second fraction here. I have x plus 7 over x plus 7, so I know I can cancel those two. I can't cancel x minus 5 with x plus 2. So now let me look between the fractions and see if there's anything I can cancel. And in fact there is. I have an x minus 5 in the denominator over here, and I have an x minus 5 in the numerator over here, so those will cancel with each other as well. As you can see now, the only thing I have left is an x minus 3 in the numerator of our first fraction and an x plus 2 in the denominator of our second fraction. So when I multiply across, really this is x minus 3 times 1. All I'm left with here in the numerator is 1 when I cancel both of these factors. And same thing here, I'm left with just 1 in the denominator when I cancel x minus 5 and x plus 4. So I get 1 times x plus 2, or just x plus 2. So that was a much faster and simpler way of multiplying these rational expressions than just multiplying through the numerators and the denominators without first factoring. So that's how you multiply rational expressions.